Hi, this is Mr. Urrego, and today we're going to talk about the unit circle. I think this is one of the most, if not the most important topic on trigonometry. We're going to talk about how do we find this coordinates, okay? Because that's going to give me what's going to come later on as cosine and sine. And with those two, we can find any other trigonometric function: tangent, cotangent, cosecant, and secant. Okay? So, the main thing is the following. I have my unit circle here. It's blank. There's nothing around it. Nothing. We're going to fill every single one of these coordinate pairs. Okay? Order pairs. The whole idea with this is because, like I said before, every order pair, like for example the first one, okay, the first one is gonna give me a 1 0, and I'm gonna explain in a minute why 1 0. But later on, whatever is my value of x will be the cosine of whatever angle I'm talking about, and the second value is gonna be the sine of whatever value. In this case right now, we're talking about the 0 degree angle, okay? Or in radians, pi radians, okay? RAD. So the first thing we're going to do is we're going to try to fill the unit circle with the angles. And we're going to do it in degrees and in radians, in terms of pi. Normally when we talk about an angle in standard position is because the x, the positive x, is going to be the 0 degrees line. Okay, so the angle will be 0. If you see the circle right there, is 0 degrees. Okay, every single one of these lines, the big ones, if you notice, this is 90 degrees from here to here. That's 90 degrees, and I'm dividing that 90 into 1, 2, 3 pieces. Therefore, each piece is 30 degrees. So this is 30, this is another 30, and this is another 30. Therefore, my first 30, obviously, is going to be 30, plus 30, that's going to be 60, plus another 30, that's going to be 90. Okay? Now, if you notice, there's another one here in the middle. Okay? And you're going to have that line always in the middle of those two 30 degree angles. That's going to be my 45 degree angle. So this is going to be 45. Okay? Now let's think about 45s. This is 45, but again, this whole thing, this angle that I'm doing, I'm going to do it in green. This angle is 90 degree again. So this is 45 plus 45 is 90 plus another 45. So it's 90 plus 45. That's going to give me 135 plus another 45. That's going to give me 180 plus another 45. That's 225 plus another 45. That's 270 plus another 45. That's going to be what, 315? Yeah, 315. And if I do another 45, that will be 360 degrees, which is the same thing as 0 degrees. And here we go again. Okay, so one full revolution, what I just said, that 360 is called one revolution. 360 is called one revolution. And every time I go over 360, I start again with the basic angles. Okay, I just did in terms of 45s. Okay, let's go back to the 30s. Okay, so again, my 90 degree angle, which is this, is divided into 1, 2, 3 pieces. Okay, if you notice, those lines keep going. So I have 30, I have 60, I have 90, plus 30, that's 120, plus another 30, that's 150, plus another 30, that'll be 180, plus another 30, oh, I put the 225 in the wrong spot. This 225 goes over here. That 225 goes over here. I'm sorry about that. So I was at 180, and I'm adding by 30s. This 180 plus 30 was going to be 210, plus another 30, that's 240, plus another 30, we get 270, plus another 30, we get 300, plus another 30, we get 330, plus another 30, we go back to 360 and keep going over and over again. So I think I erased the 45s. So now we should have a circle like this. We have 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 70, 300, 315, 330, 360 again. So we start at 0 and we ended up with 360. Okay? So now we need, as you see, I have that in pi radians as well. So now we need that. Okay. So we have this. Now we have this. We need to write on the inside here, on the inside, we need to write that, those angles in terms of pi radians, because that's the way we process in trigonometry. We need to work with pi radians. So the basic conversion unit is pi equals 180. Okay? So if I have 30 degrees and I need to turn that into pi radians, what I'm going to do is I'm going to multiply by a fraction. Okay? And I'm going to use this conversion unit. Okay, these are angle, this is degrees. So if I have degrees, okay, and I'm looking for pi radians, then I'll put pi on the top and degrees on the bottom. So that will give me pi over 180. Why? Because in that way I can cancel degrees from the top, degrees from the bottom, and my answer is going to be given in pi radians. So now we have 30 times pi over 180. I make this a fraction as well. Okay, top with top, bottom with bottom. Or we just simply reduce top and bottom. We cancel one of the zeros, divided by 3 is going to be giving me 1, divided by 3 is going to give me 6. So 30 degrees is the same as pi over 6. Okay, or the process or the thinking basically is the following. If you have 30 degrees, okay, by one number you need to divide 180 for you to get 30, and you need to divide it by 6, then your answer is pi over 6. Okay, so that's the thinking, that's how I do it fast. Okay, let me recap. I'm not sure, I stopped the recording, but I don't know where did I stop it. Alright, so I was saying, let's do the 45 degree angle. Let's do the 45 degree angle. 45 degree angle. The thinking is, I have pi over here and I have 180 over here. Alright? My thinking to do the fast is, by one number do I need to divide 180 to get 45? Whatever number I put here, I'm going to put here. Alright? That's the thinking to do it fast. So to get 45 from 180, I need to divide by 4. So if I divide 180 by 4 and I get 45, therefore I need to divide pi by 4. Therefore, 45 is pi over 4. Okay? Same process with every single angle. Let's do a bigger angle. Let's do 120, for example. 120. Maybe the process now is not as simple as the other one, but what I'm going to do is I'm going to do the conversion unit that I have here on the top. So because I have 180 degrees, okay, I'm going to multiply by a fraction. I need to put 180 degrees on the bottom because degrees has to cancel with degrees from the bottom. Therefore, the pi goes on the top. Okay. Now I make that 120 into over 1, and I start reducing. 0 from the top, 0 from the bottom. Now our number goes into 12 and 18, 6. So 12 divided by 6 is 2. 18 divided by 6 is 3. So I'm going to have 2 pi over 3. So 120 is 2 pi over 3. Okay. 225. Let's say 225. Most of these calculations you don't have to use calculator. The whole idea for this is not to use calculator at all. That's why we showing you the unit circle. So again, I always use this conversion unit. So let's say that 225, which is a big number, I guess. I have 225 degrees times the fraction. Okay. I need to put my degrees on the bottom because I have to cancel the units, 180, 180, and I pi on the top. Reduce by 5s, by whatever you can. Alright, in this case I can reduce by 5s. So 22, 5 is 4, 2 left, 25 is 5. So I'm dividing by 5, so 18 divided by 5 is 3, 3 left, 30. 6. Am I doing this right? Okay, yes. Now you divide it by 4, let me see, is one number goes on both. 45, 3, that's 15, that's 12. Yeah, divided by 3 is 9. Divided by 3 is 12. So I have so far this. Divided by, no, I think, no, hold on, I made a mistake. Divided by 3. Divided by 3 is 15. Whoa, what's going on with me? Okay, 45 divided by 3, I'm saying 45 divided by 3 is 15. 36 divided by 3 is 12. So I have 15 over 12. That 3 goes also. So divided by 3 is 5. Divided by 3 is 4. There we go. A lot of reducing. But I find out that 225 degrees is 5 pi over 4. So it is right here, 5 pi over 4. So in general, that's how you do it. That's how you convert all those angles. Okay. Let me see what we're gonna do next. Okay, so again, we do all these conversion units, and we just complete. Oh, I erase. Okay, I'll complete all the unit circle. Okay. At the end, we should get something like this over here. Alright, this is my clean copy, I guess. Now we have the inside. We have all these inside now. We have all those angles which you need to remember. You need to memorize those. Okay, try to think in something that a process that is simple for you to turn from degrees to radians, and from radians to degrees, which is the opposite. Okay. Now we're gonna fill all this in the outside. To fill that on the outside, the whole thing is we need to learn my first quadrant. Okay, that's all what I need to know. If I learn my first quadrant, then I'm going to be able to do all the other quadrants. And what I'm saying is the following. My unit circle, oh, and I haven't said that yet, I guess. My unit circle, let's go back to the original. My unit circle is called unit circle. It's called unit circle because the circle itself has a radius of 1 unit. 1 unit circle. 1 unit. So all my radius all around it, okay, from the middle to any point, alright, that is equal to 1. And I'm going to use that in a minute to find the coordinates of every single order pair. All those parentheses that we have around it, that's what we need to fill out. Okay, we need to fill those out. Let me erase and we continue. Let's start by saying that, let's go back to this. Let me take the first one. I said that this angle was 30-degree angles. Now, obviously, and like I said before, is the angle standard form. So this angle is 30 degrees. Okay, I'm going to extend this hypotenuse until it reaches my circle. Now, as we said before, is the unit circle. Therefore, that length of the hypotenuse is 1. What I'm going to do is I'm going to make a triangle. Okay, so now I'm going to go from the origin to the circumference of the circle, and I'm going to make a right triangle. Okay, you see that? And now I have a 30-degree triangle. Okay, which I have the hypotenuse on the side. Alright, on a previous video I explained how to do this, but let me go it again. Now, from here I'm going to use a little bit of geometry. I'm going to go next to next page, and as you can see, I have my 30-degree angle. From geometry, okay, there's a couple ratios. If this is 30 degrees, like I have here, then whatever measure I have here on my short side, okay, opposite to the 30-degree angle is a short leg. Here on the top will be a 60-degree angle, and here is my right angle. So opposite to the 30 is the short leg, opposite to the 60 is the long leg. Okay, this is always the hypotenuse. Alright, what am I saying that is because you can learn that as well. You can do this from geometry. If my short leg over here on the opposite to the 30 degree, if this has a measure of x, whatever it might be, then your hypotenuse is going to be twice whatever this measure is. Alright, and your long leg, which is opposite to the 60, it will be square root 3 times whatever measure you have there. Okay, that always works, always, no matter what measure you have for x. Okay, now let's get to my triangle. My triangle right now, we don't have the short leg. If we go back, we said that we have my hypotenuse, which is 1. So in that case, I know this for a fact. That I know that that value is 1. Let's just do a little bit of algebra, which is really simple math only. And if this is 1, then obviously my short leg is half of whatever I have here, right? Because if my short leg is x and my hypotenuse is 2x, then let's pretend that my x is 3, then my hypotenuse is 6. Okay? But in this case, what I have here is that my hypotenuse is 1, therefore this is half. So now we have this half. So now we have two pieces of the right triangle. I need to get this. Let's not call it x because I don't want to confuse people. Let's call it I don't know, p. There we go. That will be this side of the triangle. For that, I'm going to use the Pentagon Theorem. Okay, a squared plus b squared equals c squared. Okay, and the a could be either the p or the 1/2. So I'm going to replace this by 1/2 squared plus p squared equals 1 squared. From there, the whole idea is to find the value of x. The value of x. I'm sorry, the value of p in this case. 1/2 squared is going to be 1/4 plus p squared equals 1. 1 squared is 1. Minus 1/4. Let's do this math real quick because this is not the whole idea. Now, I have 1 minus 1/4. 1 minus 1/4. I need to have the same denominator. So I'll multiply by 4 here, by 4 there. And I'm going to get 4/4 minus 1/4, which is 3/4. I did this work to put it over here. Okay. Now I have p squared equals 3/4. then I need to do square root. P is going to give me plus or minus square root 3 over square root 4. I'm just breaking that fraction. And because I'm talking about a triangle, then obviously all the segments have to be positive. This is not negative, so I'm not using the negative part of it. Okay, like I said, when I did the square root, I got a plus or minus, but I'm not using the negative because I'm talking about distance, so it's positive. Now I solve this, and I have P equals square root 3. I'm not using calculator, so it stays the same, but square root of 4 is 2. So I find out that the missing length is square root 3 over 2. So instead of P, I'm going to erase this P now, and I have that little piece is square root 3 over 2. Alright, now we have a lot of information. So let me bring that to the previous graph. The opposite is 1/2, and this bottom is square root 3 over 2. So let's erase this circle. Okay, and like I said, let me erase this little piece, and I said this is 1/2, and this bottom is square root 3 over 2. Alright, now let's go back again to geometry. I need to find the corners of this parenthesis, which that parenthesis belongs to this point. So from the origin to that point, I need to go x, which is this bottom part, and then I need to do y. Okay, you see that? Origin, I go x, and then I go y. Alright, but my x is square root 3 over 2. And then when I go on y, is 1/2. So the corners of that point are square root 3 over 2, comma 1/2. So this is your x, and this is your y. So that's why we use that triangle. That's why we use these dimensions to locate it, to put it inside the unit circle, so it can help us out to find those coordinates. Alright, so let me go back to the last figure. You see that? Square root 3 over 2, 1/2. That belongs to this point, which is my 30-degree angle. Okay, let me show you now the 45-45, or just flip. Hold on to that. I'm going to use the same triangle. I have the 30-60, right? I have that. That's my triangle. That's what I'm going to do with the 30-60-90 as well, and the 45-45-90. Now I just wanted to look over here real quick. You see that in my first order pair I have square root 3 over 2, comma 1/2. In the next one, which belongs to, this is my 60 degree. My order pair is flipping. What used to be y now is x, and what used to be x now is y. Let me show you why. I have my triangle. I have my 30-60-90 triangle. Let me erase so I can make some space over here. Now, the only thing that I want is I need to locate those triangles in standard position. Standard position, I mean this. Let me show the standard position. My standard position, my angle in standard position is basically, I need to start from 0, okay? And my 60-degree angle now is this. That's my 60-degree angle, okay? Because this is the 60, okay? So what I'm going to do is I'm going to build my triangle. You see that? That's my hypotenuse, and I'm going to make a right triangle right there, all right? So my hypotenuse is straight down, okay? And this is my 60-degree angle. Now, if that's 60, the top is 30. So basically, I'm using the same triangle. Look, I have a 60-degree angle here, and I have a 30-degree angle there. The only thing that I need to do is put it in a different position. Now this is 60, and this is 30. But again, the dimensions of the triangle, they haven't changed. The hypotenuse is still 1, right? That's the whole idea. This is my 90-degree angle. So opposite to the 30-degree angle is 1/2. Opposite to the 30 is 1/2. Opposite to the 60 is square root 3 over 2. Opposite to the 60 is square root 3 over 2. Alright? So now I just need my triangle like this. Let me bring those two. So now my x is going to be 1/2 and the y is going to be square root 3 over 2. My x over here in the bottom is going to be 1/2 and the y I said was going to be square root 3 over 2. Now let's write these coordinates over here on the top. I go from the origin, I go in x 1/2 and then I go up to the point. Alright, again, origin x 1/2 up to the point, and that side is square root 3 over 2, which is the opposite of that. So if you have 30, you flip it and you get 60, and you keep going all over the circle. The last one that we're going to do is the 45 degree. So now we have 30, we have 60, and we're going to go 45. So to do 45, I'm going to use this triangle, 45, 45, 90, from geometry, but I'll explain it in a minute. Let me erase first. The 45, 45 can be explained really easily. Again, we're starting from having a hypotenuse equals to 1. Okay, remember it's a unit circle. So now I'm going to go 45, which is this middle one. The length of that is 1. That's my hypotenuse. So I need to make my triangle. All those triangles are going to be right triangles. Okay, if this is 45, then this is 45. Let me go to the next page so we can work on that better. So I have my triangle. That's 1. This is 45. This is 45, which gives me an isosceles triangle. So whatever the measure is this is going to be over here. Now I do the Pythagorean theorem. Let me work it on that, and then I'll keep going. Now I have my Pythagorean theorem. A squared plus b squared equals c squared. I replace a by x, b by x. The hypotenuse is 1. So x squared plus x squared equals 1 squared. X squared plus x squared is 2x squared. Divided by 2 is 1/2. Now I need to do my square root. Square root on both sides. I'm going to have a break the fraction. It's going to be square root of 1 over square root of 2. But now, a couple things. Square root of 1 is 1. Square root of 2 is 2. Can I have a radical denominator? No, that means you need to rationalize. And that's going to give you square root of 2 over 2, I'm sorry, on the bottom, square root of 4, which is square root of 2 over 2. So x is square root of 2 over 2. Now, I'm going to replace that over here. So again, that's going to be my coordinates in the next one. So this is square root 2 over 2, square root 2 over 2, and I'm running out of time right now. So both are the same, the x and the y. So let me go over here, bottom, square root 2 over 2, side square root 2 over 2. Same thinking. You're going from the origin on x first. So now I'm gonna fill that order pair. I'm gonna fill that order pair. So I'm gonna have square root 2 over 2 here. So again, origin. Okay, I don't know where this thing stopped me, but let me go back again. We have the dimensions already on the x and the y. Let me transfer that. So square root 2 over 2 on both. So on the bottom, this is 45 degrees. I'm going to have square root 2 over 2 over here, square root 2 over 2 over there. Again, I need to fill this coordinates on the side. So my x, I remember, I start from the origin. X is square root 2 over 2, and the y is square root 2 over 2. And I'm out of time. I'll explain how you rotate that to Q2, Q3, and Q4 on the next video. Study, please.